Hey, this is Dr. B, and I'd like to introduce you to the rates unit, also known as kinetics, as you see here. This is a one-page summary which shows you everything that you'll be learning about kinetics. We'll start by looking at different ways that we can plot the rate of a reaction, that is to measure it over time. Oftentimes it's not linear, so although we can determine an average reaction rate, this curve, which we know as the integrated reaction rate, is oftentimes more useful. We can also come up with the rate of reaction at any given point in time. That's known as the instantaneous rate. And finally, there's also the initial rate, which is the instantaneous rate right when it begins. That would be right at that point where you're tangential to the curve. So fine, lots of ways you can measure the rate of reaction. We can also take a look at rate law, which is an observation that oftentimes when you change the concentration of reactants, you get a predictable result. You'll either have no effect at all, you add more stuff, it has no effect on the rate, or you have a proportional effect, meaning when you double the concentration, it doubles the rate, or sometimes you have an exponential effect where you double the concentration and perhaps it will quadruple the rate, or even make it go 8 times faster. We call those zeroth, first, and second order reactions. I think that last one was even a third order reaction, and we can plot them in various ways. Finally, we can see how the activation energy of a reaction, the energy required to get things going, is related to the kinetics of a reaction using something called the Arrhenius equation. Using that and using this as well, rate law, comes up with something that we know as the rate constant. And I just typically think of that as something where a low number means a relatively low rate, a high rate constant means a faster rate. And finally, we will take a look at what most people actually do to change the rate of a reaction, and that is they heat it up. And as a general rule, this Arrhenius equation shows that the rate should double for every 10-degree increase in temperature, which is pretty dramatic. Now, oftentimes, if you're actually performing a very slow reaction and you try heating it up, you'll say to yourself, I'm not getting this doubling effect by just raising it 10 degrees. And that's probably because 2 times nothing is still nothing. Your reaction is going so slow that even increasing the temperature is not going to have much of an effect. Okay, that's an overall introduction to kinetics. Welcome aboard.